Welcome to the Roboticist Chronicles, an ARC Specialties podcast, where we get into the nuts and bolts of robots, automation, and the implications of an evolving machine workforce.
Hello, this is Dan Alford, and you're listening to the Roboticist Chronicles. We have a repeat offender on with us today, Jaxon Baker. Welcome back.
Yeah, feels good. Feels good to be back. I'm excited.
So, we got to do a little history lesson here. So, we met you at a race car party, and I hired you that night.
Yes, sir. Yeah, I'd worked with Craig McCormick for a little bit, just renting on cars, and I was doing the SAE Baja team at the same time. So, I guess that worked for you. I don't know.
Oh no, I'm fond of race car people, so it worked out fine. Then you interned with us over Christmas, and then you went back to school. So that's the connection.
Yeah.
And so, Craig, you were actually working on his race car, and I raced against him. And so I knew that you could build a good car because he's hard to beat.
Yeah, I mean, maybe he's just a good driver. I don't know if I was doing that much.
But you're a student at A&M. You're a rising senior this year?
Yes, sir. Yeah, doing mechanical engineering, about to graduate in May, so I'm really excited to get out there and start making money.
I always say, when we're doing an interview, what's the point? And the thing that intrigues me about what you're doing is Formula SAE. It's a program I wholeheartedly approve of. It's something I look for on students' resumes. Explain to us what Formula Baja, well, you actually started Formula Baja, didn't you? So explain both, Baja and SAE.
Yeah, so I mean, at the core, the goal of both programs is to get students hands-on engineering experience so they can kind of have a leg up on other candidates for getting jobs, and then just go right into a workplace environment with that like hands-on design experience. So you're building a car, right, and everybody gets their own part. So you get to see your part from conception through decision matrices, and then working with other people to make sure everything comes together into one big whole. Just seeing it through its design phase, and then get into the machine shop, and you get to cut it if you're good enough at that, and then just getting to see everything, put it all together yourself, from like conception to final product.
You know how cool that is? I built a couple of dune buggies, but not to the degree that you build cars, because you guys are building the tubular frame, you're making the engine mounts, you're designing the steering box, all the steering geometry, all the linkage. It's amazing what you guys accomplished. And is this a class or is this extracurricular?
So the Baja team is just extracurricular, so it's kind of hard to work doing that around school and with life, but. This year I'm doing the Formula team, and that'll be for my senior Capstone project. So I'm actually getting credit for it, and that just means I can put more time into it. So I'm really excited about that.
Well, that's one of the reasons I look for this on kids' resumes when they apply to ARC Specialties, is because they've taken the time to do an extracurricular activity, which is extremely challenging, in my opinion, very credible. Because designing and building a race car is one thing, but to actually have it function is another. I heard y'all had a pretty good year this year.
Yeah. So we ended up with the first Baja trophy going to A&M in the program's history. So I'm super excited about that. The team shaved my head.
I was wondering about the hairdo.
So yeah, I missed the hair, but hopefully it'll come back soon. But yeah, we finished third overall with in the acceleration event. That's where the trophy came from, and then we did 18th in maneuverability. 22nd in design, and 31st in the endurance event. We had a pretty catastrophic failure there. We were doing really well, and I ended up like fatiguing the back half of the chassis, just sheared off. So
I think that's great, because guess what? Now you guys are a little more aware of the potential for failure under fatigue, which is, a lot of young engineers underappreciate the problems with fatigue.
Yeah, it was a very, very interesting failure, and we'd actually seen it in testing before too. So
you knew what was going to happen.
We did, and we thought we had a fix for it, but I mean, it's just like light cyclical loading over time, like it surprised me. I was driving the car this year, so I was just baffled at everything. But I mean, overall, we had a really good finish. I think we also did. I think we placed somewhere like 15th for hill climb as well. So I think overall we did really well as a team. It was very much a mixed bag. We had a lot of failures during comp. That's how we did so well in acceleration, is we built kind of a glass cannon of a car this year. But the car...
What's a glass cannon?
Just like something, it performs really well, but it loves to break. So, but yeah, I think the team overall, like we just had a really really good team chemistry. Had a lot of smart guys on the team. So yeah, I mean, with that, like success was inevitable. We had just really good communication, and everybody was just very dedicated and working towards that goal. So I mean, that's all you can ask for right there.
So the team had to not only design, but cut and weld and wire and machine. I mean, you're literally building the car from raw materials.
Yeah, we try to do everything, or as much as possible, like custom in-house, just because that's where you get like the fullest design experience, and then also you're able to like optimize that part around the competition more. This year, the only things that we did off the shelf were CV joints. The engine, it's a spec motor.
So the constant velocity joints are at each wheel, the CV joints?
Yeah. The CV joints are off the shelf, and then shocks are also off the shelf, and brake calipers. But everything else on the car is fully custom and in-house. We got to do a lot of cool stuff this year. Got our hands wet with machining titanium, which was very difficult, but I mean it yielded a really good product. So yeah, I'm really really happy with how the car came out.
And I don't count against you that you had failures, because on a race car you're running very minimal safety margins. That's called racing. Because if you built it strong enough to last forever, you'd never win a race, would you?
Yeah. The competition is super tight. Every team is like everybody's got the same goal of getting first, and so you got to really kind of like find that fine line, and sometimes you end up pushing it. The lines get blurred, especially in Baja, where you don't know what the car is going to see. You don't know what the track is going to look like. So you could design around like a 5-foot drop for your suspension, and then end up seeing an 8-foot drop during the competition. And so it's kind of like, it's a fine line between overbuilding and underbuilding the car. And you really never know what you're going to get. So there's a little bit of luck in it as well there. But yeah, I mean... I think like outside of luck, I think we did like a really good job. I think we got unlucky in a lot of areas, but I mean I'm not going to go into that. And that's just part of racing too, and part of really life is like you're going to get things that you don't expect, and it's not always going to be sunshine and rainbows, but you just got to roll with the punches, and I think we did a really good job with that, just kind of dealing with the issues that were thrown at us over competition.
What do they say? No plan works after first contact. So,
yeah.
In racing, in particularly the case. But no, I was delighted that y'all had a fatigue failure, because do you recall the failure they had on the airliner in Hawaii many years ago? I don't know if they still study that in school. The whole top fatigued off of the airliner. And they sucked out a stewardess. She didn't make it. But
Wow.
And so that was a fatigue failure. So obviously the plane was loaded well below the tensile strength of the machine. But in Hawaii, it's little short jumps. And so they were landing and taking off more times. And so the engineers did not predict it, that they would have a fatigue failure. So it's a real deal. Airplanes and race cars are kind of similar. Neither one of them has a very big safety margin.
Yeah, especially with like airplanes being majority comprised of aluminum too. Aluminum, no matter what you do, you can't get unlimited fatigue life out of aluminum. So
how about steel?
Steel you can. So steel, Baja we never did. Gear, like doing gear design, I was always kind of pushing the limits to like just thin out that material. But yeah, steel you can achieve like unlimited fatigue life, which is pretty nice. One of the great benefits of steel.
What's the worst weight on a race car, in your opinion?
The worst weight?
Yeah, where if you could take weight off a race car, where would you take it off?
You want to take it out of the wheels first.
Right, because that's unsprung rotating weight.
Yep.
Precisely.
And you're also, the wheels are usually at the furthest ends of the vehicle, so you're removing your yaw inertia as well in the car, so you're able to corner faster.
Polar inertia. Yeah, the polar moment's reduced. Yeah. No, you're right on. And how would you learn this in a classroom? I just don't think you can learn it as well or as vividly as you can out there on the racetrack. When the wheel falls off, there's no denying what happened.
Yeah, I mean, there is a considerable advantage, like kind of going through classes, and as I kind of like went from my sophomore year doing Baja to junior year doing Baja. Also, obviously I had the previous experience at Baja, but like your classes do give you an advantage for sure. But I mean, yeah, you have to go way beyond the scope of what your classes go over in order to actually make things work. And then like that goes into like just testing as well. Like that's something that's really not touched on in school at all, is when something does fail, it's like, how do you identify that failure, and then how do you adapt for it, is another big thing that school doesn't really cover. But it is really just like accelerated learning process. So you're just thrown in. You have to force yourself to learn at a way quicker rate, but I mean, you come out a way better engineer. So. And
you get undeniable results when the car's sitting there on 3 wheels.
Oh yeah,
yep. Yeah, that's better than seeing it on paper. We had a similar thing here on the system that Craig McCormick started that we're building. It's for the offshore drill rigs. It's a simple part. It was just a spring. It was a detent on a ratchet. Seemingly trivial, but we found we had a fatigue failure right here, and so my guys, I think they drastically oversolved it. They ended up with a multi-element leaf spring, but we still weren't convinced because there's no tolerance for failure offshore because the prices are so high.
Yeah.
No one will get hurt, but it just costs a lot to have failures. And so guess what? I didn't show it to you this morning when we toured, but one of my young engineers has just built a fatigue machine. He needed 7,000 cycles to operate for a year, so he's looking for 14,000 to have a safety factor. We're up over 20,000 cycles, so I think he fixed
nice.
it. Yeah.
Awesome.
But it was one of those ones where intuition failed us, but we learned a great lesson, got to build a fatigue tester, which I always enjoy building testing machines, but fatigue is very real.
Yeah. Yep.
I always tell the story about my crew chief on my race car, Richard Pedersen. He works at NASA. When he got out of school, he was at UT Austin. Everybody that applied to NASA that year had a ME degree from UT Austin. They all had a 4.0, but the difference was Richard had Formula SAE on his resume, and he's been at NASA for over 30 years. So it's not just me that believes that Formula SAE is credible. The bosses at NASA agree that anybody that's able to actually design and build a race car and make it work at least deserves consideration in the hiring process.
Yeah, it's I mean, I've said it before and I'll say it again. It's truly a special experience, and I would do it again every single time. I'm pretty upset this is my last year of it, so gonna make the most of it though. I'm really excited for this year.
Do y'all have engineer mentors on this stuff, or is it all just students and instructors?
Yep, just students. We have an advisor, and he likes being hands off. Just because, I mean, like he's seen it, and he knows what works and what doesn't work. He doesn't want to spoil it for us. So, but we do have design reviews, and if something looks very off, you usually have a lot of smart guys who've done this before and who know a little bit more about what they're doing, come in and give redirection.
That's what I do with my high school robot kids. If they're doing something that is marginal, I let them do it because you learn from failure.
Yeah.
But if it's going to be catastrophic, I tend to discourage that kind of activity. But interesting. So you're a rising senior. You on the 5-year plan or the 4-year plan?
I'm on the 4-year plan.
What?
Yep. And so,
That's pretty unheard of, isn't it?
Yeah, let's hope everything goes to plan. But after this past year, I kind of made it over the hump of super difficult classes. That's what junior year is known for. And now, from here on out, I'm pretty much doing Formula full time. So
Really?
yeah, I have that and a couple other tech electives that I'm actually really excited about taking.
What are you taking?
I'm taking an automotive engineering class,
Good.
Which will be obviously super fun. I get to learn a lot of MATLAB there, and then machine.
What's MATLAB?
MATLAB is a like a coding. It's a coding program. It's very like Python adjacent, but has I think its data structures are a little bit easier to navigate. So, or that's what I've heard. I've grown up on Python, so I mean that's kind of where I excel. But just kind of building onto my resume, I know a lot of people use MATLAB, so just the more tools that I have, the better. So I mean,
What's the other elective?
the other elective is machine elements, and then it's just another fatigue class.
Oh, good.
And then I'm taking a compressed air systems class as well, so I'm really excited about that. I feel like everywhere I've gone, I've ended up working with some sort of something or other compressed air systems. Like at my internship this summer, I worked a lot with like different O-ring designs and just doing like fatigue analysis on O-rings, different sealing pressures. That was one of the products that I worked on. I had really got to dive into the Parker O-ring handbook, which I got to learn a lot from. It's super cool.
And people think there's nothing to O-rings, but I come from the rock bit industry, and when I was with Hughes Tool way back, starting in the 70s, they had a sealing problem on a downhole rock bit, and all they did was what's the crush ratio or percentage that they like to use on an O-ring?
You usually went 15 to 20%.
Right,
crushing.
and so what Hughes did is they went higher than that. I've forgotten the number. Let's say 30%. Okay, seems pretty trivial, doesn't it? But it made it work on rolling cone rock bits, and so they patented that, believe it or not, and everybody copied it, and some major lawsuits were won all around just how much you crush the O-ring. It can be that simple.
Yeah.
Hey, back to that's fun that you're doing pneumatics and fatigue. So on a internal combustion 4-cycle engine, what closes the valves?
Springs.
How about on Formula One?
Hydraulics or pneumatics.
Pneumatics.
Yeah.
And why pneumatics? Why not springs?
You as far as I know, I'm no professional, but you get a little less hysteresis in the system, and then you're also able to have more precise actuation and more accurate movement, and then as well as reducing valve hop, which reduces knock in the motor, so you can push it to higher RPMs.
One thing I understood, it was also if you had some harmonic frequencies in the springs, they would fatigue. So I think that's interesting. Your fatigue and pneumatics might come right together.
Yeah.
I think it does in Formula One. So yeah, it all ties together, doesn't it?
Yep.
Interesting. So do you have a job?
Not yet. I'm still looking.
What do you want to do? What do you want to be when you grow up?
I know I love design engineering. I want to do design engineering. That's one thing I know for sure. Where I'm gonna go yet, I don't know, but I'll be throwing out applications from here on out. So we'll see.
Well, last time we talked, you were all about automotive and you wanted to go racing, but
I'm
not hearing that now. Something changed?
Yeah. So I really just kind of like thought about it, and I want a house for a family one day, and a lot of motorsport engineering doesn't pay as well, and
You're correct, sir.
and then also with just automotive in general, a lot of it is like you're designing for scale, which means you're shaving pennies off of the part where you can. So it's not about performance. It's about where you can save money. And with that comes a lot of documentation with the size of these companies and the amount of scale that the amount of cars that you're trying to produce. So I mean, I've learned that I don't enjoy. Obviously, I don't like documentation is a necessary evil. But I mean, the less documentation I can get away with for more like design that's kind of where I'm wanting to go, and that part of that comes with like avoiding that like high volume production.
Indeed. Well, hey, there's a solution to it. I offered $1,000 reward to my engineers for the first one that created a manual using AI, and they've done it. I think that's a great application for AI. You know, you feed in all the information. They got a pretty reasonable manual out of it. So maybe that can work around your phobia of manuals and paperwork.
Yeah. I mean, I think in the world we live in today, like I think just being able, obviously, like being able to convey like the use case, like there's gonna be like some level of like input with AI, but I mean, yeah, it's a great tool, and it's like able to do stuff like that. So, yeah, I'm a huge fan of AI. So,
well, I still think you should seriously consider robotics, because, you know, with a good robot company, you might be working in defense, nuclear, oil field, and so I hope you give us a chance to.
I mean, we still got time to talk after this, so I brought a resume with me.
Well, good. Yeah, well, right now life is good, things are good, and we're hiring people. So, no, it's if you like variety, you know, that's what we do. We're in so many different industries. So yeah, at least let us help bid up your salary. What did we miss? What else have you been up to?
So we've been talking a lot about Baja. I'm really excited for a couple reasons about the Formula team this year. So we're going to Rome for the first time ever to compete in
Really?
November. It was an invitational competition, and the team got second overall. The A&M team got second overall this past year. For the Formula internal combustion team at A&M has a super rich history of just a winning culture. We have eight titles, 8 national titles. We're looking for our 9th this year.
So for the Baja team, you brought back the first trophy, but the Formula SAE team, they've been apparently kicking butt for a few years.
Oh yeah. They have it's very much a winning culture, and so we sat down in our first meeting at the beginning of the summer, and we were establishing goals, and it was like the obvious goal is to take home that 9th trophy. So I'm really excited about that. I'm doing suspension dynamics for the team this year, so I'm kind of leaving the powertrain side and going over to the suspension side, which has been a lot of reading, and there's so much to know. It's very, very cool. I'm loving it so far. But yeah, just preparing for that Rome comp too is going to be really exciting. So yeah, I think the team has a lot of things to look forward to this year, and hopefully a 9th championship is in the books as well.
Well, I hope you do well, but from my perspective, I don't care whether you win or lose, as long as you innovate and learn something. But I know you guys like trophies, so.
Yeah, I see. That's a thing we always have trouble with too. Is like with a winning team, people kind of get scared of innovation. So
wrong answer.
Exactly. Because everybody else is going to keep progressing too. So this year it took quite a bit of persuasion, but I managed to talk a lot of the guys into a decoupled suspension. So we'll be running a decoupled suspension for the first time.
What does that mean?
So it uncouples your roll and your heave movement in the car. So and heave is still coupled with pitch, but if your car pitches forwards and backwards, you have one heave spring and heave damper to absorb that motion, and then with roll, you have a separate dedicated damper and spring just for roll. So you're able to tune your heave and pitch and then your roll independent of each other, and that makes for a lot flatter and aero platform, and then you're able to design in for a lot more like tire compliance and just limiting lateral load transfer in the case that you do. So you're able to design around your transients a lot better with a decoupled system at the expense of a little bit of money there. So a little bit of money, and it's pretty hard to design to So, but we're taking on that challenge, and we're all really excited about it.
Were you an officer on this team? Weren't you? What was your role in Baja?
So I was chief engineer for the Baja team.
Very good.
That was really fun. And then this year we haven't decided anything yet, but I think I'm gonna go out for suspension lead. Just take a little bit smaller role, just because I really want to like focus on like design and really get into it this year. Not that I didn't get to do that last year with chief engineer, but you're focusing on like the design side of things plus a whole bunch of other like administrative duties. So yeah, I'm really excited to just kind of dive in there, and but I still want to have that leadership role because I enjoy leadership, and I had a lot of fun as chief engineer. So yeah.
Did y'all use the tube bender that we bought you?
We did, yes. So we actually we had quite a bit of trouble like with bending tubes because we picked our secondary tube was 0.39 inch wall thickness, and so just starting out, whole bunch of issues kinking tubes when we were trying to bend it as
Good.
is. So,
that's how you learn.
yeah, we started sandpacking tubes and then like annealing tubes beforehand.
Excellent.
And so yeah, it was super fun to play around with. We ended up with some really cool looking control arms with the tube bender as well, and it was really like an invaluable like contribution. Like we ended up using the hell out of that thing. So.
Right, but you also learned that it's not just you throw a tube in there and it comes out bent.
Yeah.
Not at all. Now I'm curious. So you annealed some of these tubes. The one that fatigued, did you anneal it?
We didn't. It was a straight tube, actually.
Really? But you were loading in the center.
Yeah.
Aha.
So I think what happened, my theory with the fatigue failure was we were running an H-arm as our rear suspension geometry, and so you're applying a moment on the tube that it sits on, because you have both your H-arm points are attached to one tube, and we didn't have any extra bracing on that tube, and so you're just applying a repeated moment as you go into like axial loading, like cornering scenarios, especially in Baja too, when you're like building up ruts in the car, and so you're just feeding repeated axial load into the car, and so I think we didn't even fail at a weld. Our weld quality was very good.
Very good.
It was just mid tube fatigue,
Fascinating.
and I think it came from that from the moment that we were seeing in the H arm.
Excellent. Well, it's been fun. I hope you come back and bring a resume in the spring or sometime before then. But yeah, I kind of agree with you that you could probably have more fun building rockets or airplanes or something, and then going racing on the weekend. That's my solution to life too.
Yeah, that's the plan right now. That's what I'm thinking as well.
And I think, and I enjoy amateur racing more than I would professional racing. If I had to do this for a living, I might take it too seriously. Well, good deal. What do you guys need this year? You know, we got a whole audience full of potential sponsors for your race team. How do they get a hold of you, and what do you need other than cash?
So we are in need of a welder right now, actually.
MIG, TIG, stick, sub-arc?
We're all TIG with a thin wall. So yeah, we need a welder right now, and then we've decided on the ECU that we're gonna run. So we need
engine control
unit. So
unit.
Yeah, we're running a Link ECU this year, and so we'll need one of those. We decided on our dampers as well. We're running Olin dampers. So yeah, we're
Those
still
all cost money.
Oh, yep. It's looking to be a pretty expensive car this year, but
Plus, you got to fly to Rome.
Yep. Yeah. That's another thing too. Is getting the money pulled together for Rome is definitely not cheap. But
so, what's your website or your phone number? How they get a hold of you?
I'll send y'all the website over right now. Anybody who's interested in the program, just learning more about it, is willing to reach me at my phone number too. I love talking about this stuff. So yeah, and then my email as well works.
All right. Well, we'll get Johnny to put all that on this thing, and so we'll have ways to get a hold of you. Tell you what, let me work on the TIG welder.
Yeah.
I'll talk to some of the manufacturers and see if I can get a deep discount. But that still leaves you with an ECU, some Olin shocks, and a bunch of airplane tickets to Rome.
That and then stock. We always need stock material.
I heard that y'all had some bending failures, so
Yeah, yeah.
you need a little more tubing than you're actually going to end up using.
Yeah. Tube is always. We always need tubes. Um, and tires with Formula. You're cooking through tires all the time. So
How many sets do you think you'll burn up?
across testing and competition, I would imagine like 10 to 12 sets.
That's tires, right?
Yeah.
And because they only get a few heat cycles before they're no longer
Yeah, chunky
representative,
Yeah.
and you're not learning anything.
Yeah, exactly.
I've learned that the hard way. Well, excellent. Well, I applaud what you're doing with the Formula SAE and getting the engineering degree. I always get a kick out of it. You always talk about being lucky. You're not lucky. You make your own luck, and here you go doing it again with Formula SAE and as your senior project. I think you're going to do well.
Thank you.
Thanks for coming on the show.
Yeah.
We got to get you back at least one more time.
Yeah, thank you for having me. Yeah, I'm looking forward to sharing the results, hopefully good ones, for the Formula competitions this year.
Like I said, I'll settle for innovation.
All right, yep, I'll let you know.
All right, we'll have you back.